Hi, we start chapter 5, the count regression. So finally, we reached the chapter which introduced the totally different model from linear regression and logistic regression. So an overview. So in this chapter, the response variable y is a count variable. So possible values are 0, 1, 2, 3, up to infinity. And the count regression models estimate the parameters theta in general of random variables for counts by MLE. So we have some distribution that we will discuss several ones, such as the Poisson regression and also negative binomial regression and distribution and so on. But anyway, the concept is that the count variable follows some distribution with continuous parameter theta. So the y is the count variable. So y is discrete, but still the parameter is continuous. So every theory for parameter still holds. And this model is somewhat similar to logistic regression because logistic regression also we are given the probability p. So p is not really the observation itself, but based on that distribution, then we get the actual response value. So if success probability is 60%, 0.6, then we have the 60% of ones and 40% of zeros. And 1 and 0 are not the parameter itself, not 0.6, but those observations are generated based on the parameter. And we have several sections in this chapter. The first one is Poisson regression. So we only have one parameter, the mu, in this Poisson regression. So in some sense, it's similar to logistic regression because logistic regression or binomial regression, we only have one parameter, p. And dispersed this Poisson model. So this is similar to over dispersion in logistic regression or binomial regression. Since we only have one parameter, we cannot control variance and it deviates from the data. So we have the one more parameter, so 2-parameter model. And section 5.3, the rate models. So this is a little bit off topic. So basically, we consider to fix some coefficient of the regression model. Fix some coefficients. And the 5.4, the negative binomial models. For count data, the one convenient thing is the existence of the negative binomial models. So negative binomial distribution have 2 parameters. So it's not the mean and the variance parameters, but at least 2 parameters represents both controls, both the expectation and the variance. So this is basically more flexible model than Poisson regression. And 5.5 is the zero inflated count models. So in some count data, the most observations are 0. For example, the number of the traffic accidents in a small town, the daily count. Then most of the days, the count is 0, but for some days in a year, the count is 1, 2, or 3. So most of the days it's 0. So that is added to the structure of Poisson regression or negative binomial regression. So basically we add one more parameters to basically boost the probability of y is equal to 0. So these are an overview of chapter 5.